If we're using stock and flow analysis to understand the scope of a system, both from a business requirement standpoint and a high-level system requirement standpoint, we eventually reach the point where we understand all the stocks that our system has to manage, and we understand, for the most part, the basic flows have to flow through that system. So this is an example of how we would extend that analysis to start discussing what the functions of the system we want to build need to be. What does its functional architecture look like as we go through? So we started with a basic stock and flow, talking about cargo moving among locations, and we ended up with system requirements of cargo moving through containers, moving through vehicles, which follow routes among facilities, which serve as our locations. So we know a lot about the scope of our system from a stock and flow standpoint, but now we want to talk in terms of what would the system have to be able to do to actually implement all of these requirements as they go through. So one of the ways we look at that is we go back to the individual stock and flow scenarios that were depicted that got us to that point. So we have flows into and out of our various stocks. We're not going to depict them that way and always talk about them that way, but the challenge here is to assign a functional name to each of those interactions, because regardless of the scope of your system, you know the system has to implement anything that would put something in a stock or anything that would take something out of a stock. There may be a lot of other things going on in your system that have nothing to do with stocks, but at the very least, the core of your processing has to implement your stocks and flows. So here are the 10 input-output functions needed to implement the flows in and out of the 5 stocks that got us here. Now, we won't bother to depict the stock and flow every time. We'll typically reduce the list just to the list of those functions. So on day 1 of our project, we already know that we have these 10 functions associated with our system in order to manage our 5 stocks and to process our 3 flows. So that's a pretty good first step toward what does the system have to do. Now, these might not be named the way your stakeholders would name them. They might look at them a very different way. This technique is generic, it's heuristic. It's meant to generate the functions you need, even if your stakeholders will end up renaming them or talking about them a different way. But the important thing is to not miss any functionality as you move your project forward. So this approach is anchored in the stock and flow diagrams in such a way that it guarantees you're not going to miss something, even if you might represent it in a way that your stakeholders aren't used to dealing with it. But it's the first cut at a functional architecture. We can then start putting those pieces together like building blocks, if you will, to say, can we turn these raw functions into the things that we've heard our stakeholders describe the system has to be able to do? And one of the things that comes up a lot in containerized cargo management is someone has to go to the location, go to the customer location, and pick up the cargo and bring it back to our terminal or bring it back to our site. So accepting the cargo, stuffing in a container, loading the container, say, on a truck, departing the customer's location to begin the transit back to the terminal, to end when we arrive at the terminal gate, and then discharge that container in the yard. Those raw functions put together constitute what is the larger scale thing our system does often, and that is go pick things up from our customer sites. Along the way, if you're paying attention to the stock and flow and the way we put together the model originally, you'll notice that for part of that pickup event, we were en route between 2 facilities. For a broader part of that, the container was on a vehicle from the depart trip to the arrive trip. And for an even broader piece, the cargo was inside a container. So we're seeing, within the pickup, we're seeing the transmission of the activity across the stock and flow framework that we had built as our project scope in the first place. Another thing we need to be able to do with our cargo in a typical cargo management company is to be able to consolidate cargo for people. It's not uncommon for someone to say, pick up a 20-foot container at one of my sites and a 20-foot container at another of my sites. Before you send it to my customer, consolidate it into a single 40-foot container to deliver to my customer sites. That's consolidation. It's taking stuff in and out of the containers it's in along the way and perhaps putting it in some others, some mixing and matching going on, services we provide. So for that, we need to strip the container and to stuff the container, but we have to invent a new process in between to just process the cargo. This process step isn't associated with an individual stock or flow, and therefore it's not yet in our functional architecture. So the process of putting together the raw pieces into larger scale steps in our business process will help us understand or identify those raw process steps that we need that might not have been generated exclusively from the stock and flow. So now we have another step called process cargo that we know our process has to be able to do. We also have to do the actual carriage, the actual put it on a vessel, take it to Europe and unload it kind of problem. The thing we do with our bread and butter, put it on a train in Jacksonville, get it off a train in Elizabeth, New Jersey. So the actual carriage of the container from place to place is something that we do. And that's loading the container, departing on the trip, doing the transit, arriving, and then discharging the container. So again, in route, in vehicle, in container is part of the carriage process. But the big part of what we do is contract of carriage, which is moving containers around the world. The last thing we put on the list, just to be complete, is at the other end, we've got to deliver things to customers. So we have to load the container on a truck, depart from and transit out to the customer site, discharge a container at the customer site so that we can strip the container and deliver the cargo. Now, sometimes they'll do the last couple of steps themselves, but overall, our system has to make sure that happens. And again, we have an in-route, in-vehicle, and in-container view as we go through that. So the four basic things that a cargo management system has to be able to do is pick things up, consolidate them, carry them around the world, and deliver them to customers. So there's our four high-level processes going through. Notice that two of them, pickup and delivery, actually just had a special case of carriage. So whether you're carrying it from port to port or from your terminal to a customer, picking up at a customer site or delivering to a customer site is really just a special case of carriage. So we can do some collapsing there by naming some bigger processes. We don't need to repeat that process 3 times and do 3 sets of requirements and 3 sets of design and things of that nature. So we'll typically abbreviate that to say the pickup ends with a carriage and the delivery begins with a carriage. But that way we only have the carriage logic, that in-route, in-vehicle, in-container construct documented once in our system flow. So we've now expanded our functional architecture, not just to include the raw functions now that includes the processing of cargo, but also 4 of the major intermediary functions that we actually define. So I can go meet with my stakeholders and do my systems engineering at any of these levels of detail, down at the raw function level or at the high level to talk to someone about how you do delivery or how you schedule delivery, things of that nature. And again, always remember we're managing 5 stocks and we're processing 3 flows through this system. So if I put some of these pieces together, I can start to see how the business system starts to shape up in terms of what's happening. So let's suppose I have a customer order where I've got to do 2 different pickups. One, pickup in DeLand, Florida, say, that I'm going to put on a truck and bring to my terminal in Jacksonville. Another I'm going to pick up at a customer site in Atlanta. I'm going to put that on a truck and drive it to my terminal site in Savannah. I might then need to do a carriage to take that Atlanta-based cargo by rail to the Jacksonville site, because I need them both at the same site, because perhaps the customer has asked us to consolidate all of that material into one container for further shipment, say to Europe or something of that nature. So from there, I might take that new container, maybe 2 20-foots came in and a 40-foot's going to continue. I'm going to load that on a vessel to Rotterdam out of my Jacksonville port. When I get to Rotterdam, I'm going to put it on a train to Berlin. When I get to Berlin, I'm going to put it on a truck to Hanover, where the customer site is, and that's ultimately where I deliver the site. So basically, this is a complete picture of the system, of what my system has to be able to do. To pick up cargo in DeLand, Florida, and Atlanta, Georgia, consolidate it along the way, and deliver it to a customer in Hanover, Germany. That's a pretty good snapshot of how my functional architecture gets put together. And the fact that I can use these stock and flow based processes to define the system flow in a pretty good level of detail means I probably have a pretty complete picture of what's happening in my overall process. So again, my stocks and flows are what are being processed, but the stocks and flows imply most of my functional architecture for a lot of my key functions going through. I also need to keep in mind that stock and flow won't tell you where the stocks come from. So whenever you have the management of something, in this case, I've got a series of functional architectures that are going to process my 3 flows among my 5 stocks. The stocks have to exist. So for each of the stocks, you'll typically add to your functional architecture the ability to acquire, maintain, and retire a stock. So where does a new facility come from? How do I pick new routes? How often do I buy vehicles? How often do I maintain my containers? Those questions still have to be answered by our system, and those aren't stock and flow questions. So we presume an acquire, maintain, retire triad for any of the stocks going on in our system. And that gives us a pretty complete picture of what we need to have in terms of the functional architecture going forward.